Students, normally we are representing vectors using straight lines. Let's take this straight line as AB. Okay, so we are writing the vectors using an arrow. Now, this vector is to the direction A to B, and we are reading this vector as vector AB. Right? So, this is the way to represent vectors using capital letters. Say you are representing this using a simple letter, we have to underline that, right? So, AB, vector AB is equal to A. Vector AB is equal to A, right? There we have to represent the direction correctly, right? The arrowheads represent the direction. Okay, now let's talk about negative vectors, right? Negative vector means, now let's say that this vector is vector AB. This is vector AB equals to A. As I said before, this is vector AB and that is equal to A. Right? Then we say that vector BA is equal to minus A. Now you all think about the direction. AB means towards this direction. BA means towards this direction. That means when we take the opposite direction, we have to write minus A. Okay, when the direction change, when you change the direction, this is from A to B. When we get B to A, when we take BA, that will become minus A because it is the opposite direction, right? So, negative vectors, we are getting negative vectors when the direction is opposite to the vector that we consider, direction of the vector that we consider, right? Then, vector AB is equal to minus vector BA. Right? So, what you have to get into your mind is vector, if you need to change the direction B to BA, you have to put a minus sign because we are considering in the negative, opposite direction, we have to put this minus sign. Okay, so now we are going to talk about equality of two vectors. If vector A is equal to vector B. Say two vectors are equal, right? Vector A is equal to vector B. That means magnitude of vector A, we are representing using the modular sign, right? Magnitude of vector A is equal to magnitude of vector B, right? That means if one vector is 5 newtons, the other one also should be 5, right? So, magnitude should be same. You can understand that. The other thing, next thing is vector A should be parallel to vector B. Vector A should be parallel to vector B. Okay, and the third condition is direction of vector A, right, should be equal to direction of vector B. Otherwise, we can't tell that two vectors are parallel. You have to satisfy all the, otherwise we can't tell that the two vectors are equal, right? We have to satisfy all these three conditions. Magnitude should be equal and the vectors should be parallel as well as their directions also should be same, right? If we satisfy all these three conditions, then we can tell that the two vectors are equal. So, if two vectors are equal, all these three things happen, and if you need to prove that two vectors are equal, then you need to show all these three, right? You have to prove all these three to prove that two vectors are equal, right? Okay. Now, let's move to this example. You have to think these, what I have drawn are squares, right? A, B, C, D and this one also, they are squares, right? So, now we have to mention whether AB and DC are equal or not. Okay, let's observe. As they are squares, you all know that the lengths are equal, opposite sides are equal, right? Therefore, magnitude of AB and magnitude DC are same. So, this condition is satisfied. Okay, magnitudes are equal. Now, you just think whether, let's see whether they are parallel. Vector AB and vector DC, yes, they are parallel, right? Right. So, the second condition also satisfied. Okay. What about the direction? Directions are the same. Say A to B, B to C, the same direction, right? Therefore, we can tell that the vectors are equal. But what about this one? Magnitudes are same. They are parallel because they are squares, no? They are parallel. But what about the direction? This is from A to B, this is from C to D. The directions are opposite, right? Therefore, we can't tell that they are equal. So, vector AB is not equal to vector DC. Okay, now we are going to talk about multiplication of vectors. Actually, multiplication of a vector by a scalar, right? You just think like this lambda be a, let lambda be a scalar and A be a vector. Say lambda is a scalar and A is a vector, right? So, lambda times A, that means lambda A is also a vector. If lambda is a scalar, that means once you multiply a scalar and a vector, the result will be a vector, right? So, lambda times A is a vector. The special thing is this lambda A is a vector, you can understand that, right? The special thing is this vector is parallel to A. This vector is parallel to A, right? For example, say this is vector A. Okay, say this is vector A. So, if I consider a vector 2A, that should be parallel to this vector, right? That should be parallel to this vector, but twice this, right? Parallel to this vector, but twice of this, right? But twice like this, right? So, they must be parallel and twice as it. Okay, hope you all can understand this multiplication of vectors, right? So, once this lambda is a positive value, lambda is greater than 0, that is similar to this example, right? So, the direction is same, direction of the vectors are same, right? Directions are same means direction of vector A is equal to the direction of vector lambda A, right? Direction of vector A is equal to direction of vector lambda A. But if this lambda is less than 0, that means if lambda is negative, right? If lambda is negative, then the direction is opposite. Directions are opposite, right? Directions are opposite. Right? If lambda is greater than 0, directions are same. If lambda is a negative value, then directions are opposite, right? For example, now this is vector A. What about vector minus 2A? Yeah, that's magnitude should be twice, but still the direction is to the opposite direction. Direction is to the opposite direction of vector A, right? Vector A from, let's say, A to B, right? This is towards the direction B to A, right? The opposite direction. Okay, now we are going to talk about the sum of two vectors, right? So, for that we are using two laws. One is triangle law of vector addition. Right? You just think like you have vector A here and we have vector B, right? So, I can represent these two vectors using a triangle like this. Vector A to this direction and vector B I will start from this place parallel to that vector B. I can complete this one forming a triangle, right? I will name the triangle as A, B, C. Vector A plus vector B means what? What is vector A? AB plus what is vector B? BC. According to triangle law of addition, AB plus BC, that is equal to AC. Okay, AC, that means this resultant vector is towards the direction AC, that is vector A plus B. So, the triangle law of addition is the sum of the two vectors are represented by the third side of the triangle, right? So, the easy thing here is you can see that Once you have the same two capital letters in the middle, you have to forget that and then write AC. For example, say you have PQ plus QR. Okay, this is equal to what? Forget Q, forget the letter in the middle, the common letter in the middle, the vector is equal to PR. Okay, so this always happens. Okay, so then let's talk about this parallelogram law of vector addition. If you have a vector as before, vector A and another vector B like this, I can represent this using two sides of the parallelogram, right? That is vector A and here vector B. Okay, now I am going to complete the parallelogram like this. A, B, I will name it as A, B, C, D. Okay. So now vector A plus vector B means what? Vector A means AD. AD. Vector B, AB. Okay, now to add this, as I told you before in triangle law of vector addition, you don't have this same capital letter in the middle, right? So what we can do for that, right? You all observe this, vector AB and vector DC, right? Consider vector AB and vector DC. Yes, they are parallel, the magnitudes are equal and the directions are also the same, right? That means instead of AB, I can write DC. Now, AD plus DC. Now we have the same capital letter in the middle. That means AD plus DC, that is equal to AC. What is AC? The resultant vector is given by the diagonal of the parallelogram. So, that is the parallelogram law, right? When you add two vectors, the resultant vector is given by its diagonal, right? That is the parallelogram law of vector addition. So, hope you all can understand. So, the special thing actually in vector addition, right, the special thing what you have to keep in your mind is vector, let us say vector xy plus yz. Once you add this one, you will get what? Xz, right? What you have to do is, you have to forget this, I mean you have to remove this same capital letter in the middle, right? Then we can write down the vector very easily, xz. So, we are going to discuss some properties of vector addition, right? This is the commutative law, right? That means A plus B is equal to B plus A, B plus A, right? A plus B is equal to B plus A, no problem. We can change this actually, right? There is no any issue of changing the two vectors in addition, right? Then this is associativity. There also you can understand that A plus B plus C, that is equal to A plus B plus C, right? So, simple things you can understand this. That means no any issue of doing these calculations when you are doing vector addition. Then if you have two scalars added here, lambda plus mu into A, right, we can multiply this with this vector, right, lambda A plus mu A, right, lambda A into lambda, lambda A into mu, mu A, right. Similarly, if you have a scalar here and two vectors, there also we can do the multiplication as usual, lambda into A, lambda into B, lambda B. Okay, so another important topic, position vectors, right. A vector that represents the position of any point with respect to another fixed point, that we call it a position vector. That means, now you just think you have P here and O here, and O is a fixed point. So, I am going to read this vector OP, and that is equal to R. So, OP equals R is the position vector of P with respect to O, right? So, the position vector of point P, the position vector of point P, we are getting with respect to this fixed point O, right? For another example, if I have A here, right, the position vector of point A will be OA, right? I will represent it using simple A, right? Position vector of point A is OA, right? Say you have a point S here, position vector of point S is OS, right? Position vector of point S is OS, right? Like that. This is a very simple thing, right? We are always representing the vector relevant to that particular point, right? With respect to another arbitrary fixed point. Now, let vector A and vector B be the position vectors of points A and B, right? You just think like the vector A and B are the position vectors of points A and B. That means now always I told you that position vectors are respective to a certain point. Okay, let's say O. So, position vector of A we are writing as OA. OA equals to what? Vector A. Right? Position vector of B, how to write? OB. OB is equal to B. What you have to do is you have to find AB. Right? I have taught you. Let's draw this one first. OA, OB. This is vector A and this is vector B. What you have to find is this vector AB. This is what we have to find. Okay, now let's use the triangle law of vector addition we all know. AB we can write as, right? AB, how can we write? What is the path you can use to go to B, from A to B, right? See, AO plus OB. AO plus OB. AO plus OB. That is AB, right? Now, what is vector A? What is vector A? That is OA. But what you have here? AO. That is the opposite direction of OA. So, we had to write here minus A plus OB. OB means B, right? So, that is B. Then that means vector AB means vector B minus A. B minus A. AB means AO plus OB. So, OB means B, AO means minus A, therefore, that is B minus A, right. So, that means if they give us the position vectors of 2 points, right, very easy, and ask us to find this AB, like if they ask us to say, yeah, if they ask, they have given the position vector of X and they have given the position vector of Y, okay. So, if they ask us to find X, Y, what will be our answer? XO plus OY, right? So, you just think like the position vector of Y is Y, position vector of X is X, right? XO plus OY, right? OY means Y, XO means minus X, so minus X. So, XY, Y minus X, understand the pattern. XY, you are getting Y minus X, position vector of Y minus position vector of X. That means you can write that directly, that's why, right? Now, here see AB, B minus A, B minus A, right? Okay, now let's try out this one. Position vector of P is given here, position vector of Q, and we have to find PQ. We have to find PQ. So, position vector of P is P, position vector of Q is Q. What should be PQ? Position vector of Q minus the position vector of P, right? What do you subtract is this position vector of this one, you subtract from this one, right? Q minus P. The answer is Q minus P. Position vector of P is 2P, position vector of Q is 3Q. What should be our answer? 3Q minus 2P. So, that means we can directly write this. Okay, if you need, you can actually write PQ equals PO plus OQ and then find that, no problem. But still, if you can remember this one, you can directly write PQ, right? Then this one, 3p plus 2q minus p minus q. What we need is PQ. So 3p plus 2q minus p minus q. 3p minus p, you will get 2p, 2q minus q means plus 3q. Okay, so that's all about question vectors. Hope you all can understand that part. Okay, students, now this is a very important theorem, okay, that you must know to do the sums. Okay, that is, let alpha and beta be two scalars and a and b are two vectors, right? But you must satisfy two conditions here, that is, right, these two vectors, vector a and vector b, they cannot be equal to 0, right? They cannot be equal to 0. And the other one is, these two vectors should not be parallel. They are non-parallel vectors, non-zero, non-parallel vectors, very important, right? We are considering two scalars alpha and beta, and we are considering two vectors a and b, where these two vectors are non-zero, non-parallel. If they satisfy these two conditions, then if alpha a plus beta b equals 0, right? You say that alpha a plus beta b equals 0, then alpha equals 0 and beta is equal to 0, right? If alpha a plus beta b equals 0, then alpha a equals 0 and beta equals 0. Actually, you must know to prove this theorem, right? You must know to prove this theorem, but I am not going to do this as this is a very short video, right? But you all must know to prove this for the sum 2000. I am going to discuss the level question now. So, we will need this, okay? What you remember is, alpha a plus, if alpha a plus beta b equals 0, where alpha and beta are non-zero, non-parallel vectors, then these two scalars, both the scalars should be equal to 0. Okay, students, now we are going to discuss the recent past paper question, that is 2022 A-level question. 2022 A-level question, right? Let the position vectors of the points A, B, C and D be A, B, 3A and 4B with respect to fixed origin O, where A and B are, they have mentioned that A and B are non-zero, non-parallel vectors, right? Non-zero, non-parallel vectors. Okay. First of all, let's draw this diagram. Position vectors of A, B, C, D, right? They have given like this. This is A, this is B, 3A and 4B, yes, 4B. So, position vectors of points O, A, B, position vectors of points A, B, C, D means what? What do you mean by a position vector? That is always with relative to a fixed point. Okay, let's say the fixed point is O. So, that means OA equals A, OB equals B, OC equals 3A and OD is equal to 4B. Okay, now if I draw the diagram for this one, say this point is O. What is OA? That is A. Right? And here we have another 3A there. Right? So, you all know that if this is vector A, this is 3A, what the vectors should be now? A and lambda A, they are parallel vectors. I told you that they are parallel vectors. So, this should lie on the same line because they are starting from point O. So, they should lie on the same line. Right? This is OA, right? And 3A should be 3 times like this. So, this should be, the rest of the thing should be 2A and this is what? B. I am sorry, this is C, right? Point C. So, you can see that A plus 2A, vector OC is 3A and vector OA is A. The next one, OB, we say to this direction, right? You can change the direction, this is the way I draw, right? OB, that is B. and OD is 4B. So, vector 4B should be definitely parallel to vector B, and as it is starting from the point O, that is both of them are starting from point O, they should lie on the same line. Okay. So, this is vector B, 4B should be 4 times of the length like this, and OD should be something here, right, where this is B and this part from B to D should be 3B. Okay. So, now OD is B plus 3B, 4B, and OB is B, OA is A, OC means A plus 2A, that is 3A. Hope you can understand up to this place. And you can see that these two vectors are non-zero, non-parallel vectors. Okay, that is important. E is the point of intersection of AD and BC. AD and BC. AD means this. BC means this. So, the intersection point, they have mentioned that it should be E. Right? They have given that it is E. Show that OE is equal to, A plus lambda 4B minus A, where lambda is a real number, that is a scalar, okay, and that is a real number. You have to show that OE is equal to this. Okay, you have to use, they have asked like this, using the triangle law of vector addition for the triangle OAE, for this triangle, you have to show that OE is equal to A plus lambda 4B minus A. Right. Okay, we have to find OE, right? We have to show that OE is this. Right. OE means what? Right? How to move from O to E? That is the easiest way to think. How to move from O to E, and we have to use this triangle OAE, right? Using this triangle, we have to go from O to E, right? OA plus AE. I mean, you have to use vector addition, so we have to get OA plus AE. OA plus AE. Okay. So, OA means what? OA is equal to A. OA means A. Plus AE. See, we don't know the value of AE, right? You can see that AE is part of a line, part of the line AD. It is a part of the line AD. So, we can write it as a fraction of AD, right? So, we don't know the fraction, we don't know the ratio, so I am going to use lambda, right? I am going to use this lambda. So, lambda AD, AE equals lambda AD, A plus lambda AD. Yes, now how to write AD? Yeah, how to write AD? Yes, we don't know the vector, so we have to write it. Actually, always we have to use vector addition, right? What is the path to go from A to D? AO plus OD, AO plus OD, right? Let's write AO plus OD. Can you observe that in all these additions, we are getting the same capital letter in the middle? See, OA plus AE. OE means OA plus AE, same capital letter. Here also, AO plus OD, same capital letter in between. AD means AO plus OD. Okay, let's write A plus lambda AO. So, the OA means A, right? OA means A. Then AO should be minus A. What is OD? OD, we all know that it is 4B. So, we are getting that answer we need. See, right? So, that is OE is equal to A plus lambda 4B minus A. Right? So, we can change this, no problem, with the sign, that is 4B minus A. That is the answer of the first part. So, in the next part of the question, they have asked us to show that OE is equal to B plus mu 3A minus B. Now, earlier we used the triangle OAE, right? OAE equals A plus lambda 4B minus C. So, OAE, using the triangle OAE, we wrote OE as OA plus AE. This time, we can write OE is OB plus BE. OE equals OB plus BE. OB is equal to B, right? OB means B. Then what about BE? What about BE? Observe that BE is on the line BC. B is a part of a line that is on the line BC. So, I will use a scalar to write, I will use the ratio fraction to write BE in terms of BC. We don't know the ratio, therefore, I will just use mu, right? I am targeting my question, that's why. So, mu BC, we can write as mu BC. Mu BC. B plus mu, right? What is BC? BO plus OC, the path to move to from B to C using vector addition, that is BO plus OC, right? BO plus OC. So, this is very similar to the method that we followed earlier, right? BO plus OC. What is BO? What is BO? OB means B, then BO should be minus B, right? Then OC, OC means 3A, A plus 2A, 3A. Therefore, the answer is 3A minus B. 3A minus B. Right? Then, we have to find the actual value of OE. We have to show that OE is equal to 1 over 11 9A plus 8B. We have to show that OE is equal to 1 over 11 9A plus 8B. We have to get this answer. Now, we know OE in terms of lambda, and here we know OE in terms of mu. We have two unknown terms, right? So, instead of this scalars, two scalars lambda and mu, we have to get the numerical value, numerical ratio like this 1 over 11, 9A plus 8B, we have to get this actual answer. So, when you have two unknown terms, what we can do, right? We know, so both of these ones are for OE, so these two are equal, right? So, we can form an equation with including this part and that part, that means OE is equal to OE, and then we can find lambda and mu separately, then substitute for this one, and then we can find the answer. I am going to equal the answers we got for OE, that is A plus lambda 4B minus A is equal to B plus mu 3A minus B. Okay, so these two are equal because OE, both of them equals to OE, we can write they are equal. Right? Now, here we have two scalar terms that are lambda and mu. Now, as you all know, we learned the theorem that if alpha A plus beta B equals 0, then we can get alpha equals 0 and beta equals 0 if this A and B are non-zero, non-parallel vectors. Now, in our question, they have mentioned that A and B are non-zero, non-parallel vectors, so we can apply. Now, the thing is, we have to get this format. Okay, you just observe how I am going to get. I am going to take all the things to this side, right? That is, here we have A, and here we have minus lambda A, right? Yes, and here 4 lambda B, minus B, minus 3 mu A and minus mu B equals 0, right? So, now take A common, what will remain inside the bracket? 1 minus lambda, and here you have minus 3 mu, plus, again take B out, what will remain? 4 lambda, here minus 1 and here minus mu equals 0. Now can you observe? Now this is our alpha. A plus beta B equals 0. Alpha A plus beta B equals 0. If we can satisfy this condition, A and B are not equal to 0 and A and B are not parallel, right? Then what we can write? Alpha equals 0 and beta equals 0. Then we can write alpha equals 0 and beta equals 0. Okay, so then you can write 1 minus lambda minus 3 mu equals 0 and 4 lambda minus 1 plus mu equals 0. So from this one we can find mu. Mu is equal to 1 minus 4 lambda. We can substitute this mu instead of this mu and find the value of lambda. See, 1 minus lambda minus 3 into 1 minus 4 lambda is equal to 0. Now 1 minus lambda minus 3 plus 12 lambda is equal to 0. Therefore, we are getting that 12 lambda minus lambda means 11 lambda minus 3 plus 1 minus 2. I will take it plus 2 there. So, lambda is equal to 2 over 11. Lambda is equal to 2 over 11. Right? Now, after finding the value of lambda, we can substitute that in this first equation. OA is equals A plus lambda 4B minus A and get the answer that we need. OA is equal to A plus lambda 4B minus A. This is our first equation. So, we got that lambda is equal to 2 over 11 lambda. Sorry, 2 over 11. Right? 4B minus A. Right? Now, take the common denominator as 11. Right? There you are getting 11A plus 8B minus 2A over 11. Right? So, that means 11A minus 2A means 9A. 9A plus 8B over 11 as the answer for OE. So, this question is actually very easy to do once you understand the pattern that you have to follow. Right? The most important thing is this alpha A plus beta B equals 0. Right? Then alpha equals 0 and beta equals 0 if it satisfies the conditions A and B are non-zero, non-parallel vectors.